Let's take a look at this equation. If I gave you that equation to solve, what you probably would do would be to square that binomial, which of course means to multiply times itself. So you use FOIL to multiply 2x plus 3 times 2x plus 3. And you would multiply through there. You would combine your terms and examine it to see what kind of equation you had. Well, I want to suggest a different technique to you. A technique that kind of piggybacks on what we've been doing with these equations that are quadratic in form. A substitution. Do you notice that we have a quantity here in one term that is being squared in another term? So couldn't we use the substitution technique we've been using? Only in this case, the substitution I want to make is to let y equal 2x plus 3. So y squared would be the square of that binomial. So I can replace this term with y squared. And this term becomes 3y. Wherever I had the quantity, the binomial quantity 2x plus 3, I replaced it with y. And now I have a much simpler looking quadratic equation that I can solve. The factorization of that trinomial would give us y minus 5, y plus 2. Those would be my two solutions to that quadratic equation. And now I substitute back. What was y holding the place of? 2x plus 3. And now I can solve these equations in x to get the actual answer I wanted. What would x be equal to? So I'll subtract 3 from both sides, divide by 2. One solution is x equals 1. Subtract 3 from both sides, divide by 2. The other solution is x equals negative 5 halves. And if we tested those solutions in the original equation, we find that they work. So this substitution technique can be used even in other instances, where here I had a quantity, the binomial quantity 2x plus 3. You will find this substitution technique used often as you go into higher level math. If any of you are going to be taking calculus, you will see substitution used over and over again to make a problem that looked to be a little more complex into a simpler problem to solve first, and then come back and finish your final solution to get the answers to that original equation.